Buenas and half a day, everyone. Thank you for joining us here today. My name is Marc Bituin, and I'm with my partners Kameryn, Duenas, and Jezreel Sabangan. Today, we'll be presenting on our project, which is a stormwater drainage system assessment for the University of Guam campus. With the increase of structures on campus and Guam's erratic weather, the University of Guam seeks to manage its stormwater system more effectively to accommodate these concerns. Such challenges represent an opportunity to reassess how the university will reduce the amount of runoff generated throughout the entire campus. The climate on Guam is classified as tropical, both wet and dry seasons, with low precipitation. Summers in Guam are classified by monsoon events, producing high volumes of stormwater over short periods of time. Succeeding summer is the island's rainy season, which begins around June, July, and lasts until around September. This rainy occurrences results in an overabundance of surface runoff throughout the island, including our area of focus, the University of Guam campus. The existing storm drainage system at the university accommodates frequent high-intensity over short-duration monsoon events. However, it may lead to surface runoff, polluting main water sources, and can cause deterioration to most hydraulic systems. In addition to these concerns, as stormwater runoff moves across surfaces throughout the campus, the runoff carries along trash, debris, and pollutants such as sediment, oil and grease, pesticides, and other toxics. Changes in water temperature, sediment, and pollutants from stormwater runoff can be dangerous to aquatic life, wildlife, habitats, and human health. The purpose of this project is to assess the current conditions of the storm drain system at the university. Upon doing so, proper and complete assessment must be conducted to analyze the needs of the university. Physical and environmental challenges, such as deteriorating hydraulic structures and heavy rain contributing to large volumes of debris, are the issues we will address in this assessment. Afterwards, we will be able to conduct an analysis on the system's capacity to determine if the hydraulic components are in need of an upgrade. Finally, we may also implement action plans such as housekeeping, best management practices, and or low-impact developments to mitigate stormwater pollution concerns.
The first step is data collection. We search through as-built drawings retrieved by UOG to create our own mapping of the drainage system on AutoCAD. As mentioned, our initial task was to conduct a field inventory and location of hydraulic structures such as manholes, inlets, channels, ponding basin, pervious versus impervious surfaces, and swells. Updates to the drawing was done as our project proceeded. Our next task was to create an assessment checklist of all the inlets, storm drains, and other hydraulic structures, which indicates the current conditions of all these components. Subsequently, we will be using the rational method to conduct hydrologic analysis of stormwater runoff intensity on campus. Since UOG is approximately 100 acres, which is a considerably small watershed area, we may use this method to delineate sub-watersheds and analyze the peak flow rate with respect to rainfall events. The rational method is Q equals CIA, where we found the peak flow rate considering the runoff coefficient, the rainfall intensity for chosen rainfall events, and the approximate area of watersheds. Afterwards, a GIS mapping database of the storm drainage system was created used for analysis and asset management. By the end of our project, we will be able to conclude our collected data and make recommendations for the university. Our quantitative results include using hydrologic parameters and retrieving rainfall data from NOAA to determine the peak flow rates for the outfall systems on campus. Currently, flooding is not a critical issue in the subject area. However, we conducted our analysis using 2, 5, and 100-year rainfall events data. The calculated peak flow rates indicated it is within acceptable range considering max allowable velocity according to the Guam Transportation Stormwater Drainage Manual. Moving forward, our qualitative results include findings from our field assessments demonstrating concerned conditions of various hydraulic structures on campus. Generally, we found inlets with either damaged or missing grates that obscured its purpose for draining stormwater runoff. These particular inlets need more maintenance attention, otherwise the drain will continue to have irregular functions. Debris and sediment buildup reduces the performance of drains and raises our concerns, more especially during heavy rainfall events. We also found culverts around campus that lack maintenance. Majority of them are located near the dormitories, field house, and facility and maintenance building. While some culverts were well maintained, the majority of them have major clogging issues filled with debris, overgrown grass, and sediments. These conditions also constrict proper water flow through the pipes that eventually cause ponding in the surrounding area.
We have concluded that LID or low impact development projects would best fit the mitigation of non-point source pollution that may occur on campus. Some of the LIDs we recommend are vegetative swales, bioretention cells, rain gardens, permeable pavements, and green roofs. An LID we recommend is to develop more vegetative swales around the campus to make use of the open grass fields. This will help slow down the conveyance of collected runoff and allow it more time to infiltrate the native soil beneath it, as well as improve the scenery on campus. Grass swale also manage water quality volume, slows runoff by vegetation as it flows in these channels, allowing infiltration and is filtered by underlying soil. They are also erosion resistant. We would also recommend bioretention cells at the parking lots, such as the one in English and Communications building and Humanities and Social Sciences building, because these medians can be redeveloped to provide storage, infiltration, and evaporation of both direct rainfall and runoff captured from surrounding areas. Another LID is to develop more rain gardens similar to the one near the Agriculture and Life Sciences building. At these gardens, plants and soils are specifically chosen and engineered to clean stormwater by reducing nutrients and overall sediment loads. Permeable pavements can also be installed at pedestrian walkways. They retain more rainfall on site, allows it to enter the ground and be filtered by soil as it seeps down to the water table. This can serve as a double purpose as it reduces storm runoff and replenishes groundwater, reduces flooding, pollutants, temperature, and traffic hydroplaning accidents. Lastly, for the new infrastructure buildings that are being developed for the campus, such as the new Student Success Center, a green roof can be added to the design to reduce impervious areas and convey excess percolated rainfall off of the roof. Green roofs don't only manage stormwater, but also provide reduced energy use and air pollution and improved comfort and quality life. Overall, the procedures for the system assessment have been completed. By creating and updating the stormwater system map, our group was able to conduct an assessment on the current stormwater system at the university. A GIS mapping and AutoCAD layout was created to assist with our analysis. The university may use this checklist for future improvements, such as the construction of new buildings or maintenance purposes. UOG will also be able to use these deliverables for asset management, which will help keep records of the stormwater system at UOG. From our observation and research, we have concluded that LID projects would best fit the mitigation of non-point source pollution that may occur on campus. The hydrologic analysis shows that the capacity of the storm drain system on UOG campus is sufficient to withhold Guam's erratic weather and summer monsoons. BMP, such as monthly maintenance at all hydraulic structures, and LIDs, such as installing infiltration and filtration practices and/or retention systems, are the recommendations that UOG should adapt in the future to protect the integrity of the storm drain system and mitigate the surface water runoff on campus to improve its quality. This will also improve the overall aesthetic of the campus. These practices will ensure the overall safety and protect the environment on and around the University of Guam. And this concludes our presentation. Thank you.